Hi, and welcome to Voices in the Wilderness. Our show is kind of on science and faith, and we try to address questions that are posed by Christians and skeptics and people who are just wondering how to reconcile science and faith, and people who are deconstructing or reconstructing or in various phases of their spiritual journey. So we bring voices and conversations to open paths for those who wander to connect with Jesus along their journey. If you're watching live on Facebook or on YouTube, feel free to drop your questions or comments in the chat boxes, and we'll try to bring some of those onto our show today. And today we have the pleasure of Dr. Antoine Bret. He's a PhD from Orsay University in France and a full professor at the University of Castilla-La Mancha in Spain. He's an expert in plasma physics with applications in inertial, thermonuclear fission, and astrophysics. He has been a visiting professor several times at Harvard Department of Astrophysics, and he's the author or co-author of more than 100 peer-reviewed articles. He's the author of The World is Not 6,000 Years Old, So What?, which discusses the question of the age of the universe. Thank you, Antoine, for joining us today from Madrid.
Thank you. Hello. Thank you very much.
It's great to have you here. Why don't you start by just telling us a little bit about your religious background and spiritual journey?
Okay, so I will try to make answers as short as possible, and then you can dig up here and there if you want more. But I was born in France. I was raised in France. I would say in a light Catholic environment, which means that I went through all the steps of Catholic education, but it's like being on a conveyor belt. It's just a social, and you don't really care about what's going on, which doesn't mean you're an atheist. It just means that it's a social event and a social journey, and that's it. I never, from really a young age, I knew I wanted to be a scientist. I never went atheist. I was interested in many things. I would say when I entered the equivalent of college in France, I started to read the Quran. I read a lot of on Buddhism and all that. And then I began to read the Bible. And I would say I was fascinated by Jesus. So usually when people ask me, why am I a Christian? The answer number one is because of Jesus. So that's the short answer.
That's great. I love it. And are you still Catholic or Protestant or Orthodox?
No,
What's your affiliation?
So for me, in my mind, I became a Christian at 24. I'm a rather Protestant, the French or Spain are mainly Catholic, and so evangelical is a word that's starting to be recognized. But I would say I'm a Christian. I'm no longer Catholic, and of course, as a kid, I was baptized. But for me, it was not my baptism. My baptism for me was when I was 45.
Okay.
So now I would say I'm a Protestant / evangelical / I don't really know what I am, and I don't really care. I follow Jesus.
That's okay. That's okay. That's okay. I think a lot of us have trouble finding really a label that fits, because sometimes the labels have a lot of baggage with them. So
yeah.
And Europe tends to be a lot more secularized than the U.S., right?
Yes.
So like in your work, do your colleagues know about your faith, and how do they respond to it?
Oh yeah. So I wanted to give an example, for about secularity in France or in Spain. Here it would be impossible to hear a president praying on TV. You cannot imagine them. It would ruin your career, I guess. So it's much more secular. Now, not only I'm a Protestant slash evangelical slash whatever you want, but I've been working for a church for 10 years. I've been a minister. Everyone knows about it. If you go on my personal webpage and you open my CV, it's there. And I never felt any problem with this. People in my community know about it. And from time to time, it triggers interesting conversations. But I never felt like I was marginalized because of this or criticized or whatever. Maybe in my back, but not in front. So no, I don't think it's an issue.
Okay. I've never felt an issue in my professional life with my Christianity. I have coworkers who will talk with me about it, and it's not been an issue for me in my career, which is unfortunately not the same at church for me. So.
I hate to interrupt, but I'm going to jump in and just say that we are streaming live on Facebook and on YouTube. Everything's going smoothly. If the listening audience would like to chime in with a comment or a question, we will try and include it. So welcome to the show. I don't know if I'm jumping the gun here, but Doctor, we want to talk to you about the Big Bang and its intersection with Christian apologetics. So maybe you can start by giving us a brief description of the history of the Big Bang, how it was received in science, and maybe then we can go on to how it's been received in faith.
Okay, so I would say that until the beginning of last century, scientists in majority thought the universe was eternal. It has always been there, okay? And it was also static. It was not moving and all that. And then came up Einstein with his general relativity. And I skip a lot of steps, okay? And the people like Friedman, Robertson, Walker, Lemaitre, Georges Lemaitre, who was a priest, as you surely know, solved the Einstein equation with a few hypotheses for the entire universe. And they thought, they found, they couldn't find, I would say, static solutions. The solutions were dynamic. And almost at the same time, Hubble did his observation that the further our stars, the fastest they move away from us. And it made a junction with what Friedman, Robertson, Walker, Lemaitre had found. And they say, hey, apparently the universe is an expansion, and it fits observation, and it fits general relativity. So there was a debate for a while. And in the 60s, 70s, people found what was called the smoking gun of the Big Bang. So the Big Bang, what was called the Big Bang was, I would say, something roughly the beginning of the expansion. Okay, and there's a huge misunderstanding there. I guess we'll talk about it later. And if you rewind the movie of the universe, you come back, you go. So you inverse the expansion. So you go to a really hot and dense phase. And then if you play the movie again, then the universe expands from this dense and hot phase. And you can deduce a few smoking guns that should be applied, you should be able to observe today. And the cosmic microwave background was one of them. I would say the first of them, almost. The first of them to be observed. And so I think it was in the 60s or 70s, something like this. And then, so at first in the scientific community, people resisted this idea because, yeah, it smelled like a beginning. But the scientific community changed completely. Einstein himself was converted, quote unquote, to a dynamic universe in the early 30s, I think. And since I would say the last decades of the last century, there is almost a universal consensus in cosmologists that the universe is an expansion and it's not static, and that it went in the past through this hot and dense phase. So I would say that. And there are other smoking guns, like the relative abundance of hydrogen and helium and structure formation. It's maybe more technical, but there are a lot of smoking guns that made people say, okay, it's definitely happened this way.
Do you think there's going to be any challenge with what we're learning from the James Webb Space Telescope, or do you see the additional information we're gaining confirming
I would say
the evidence?
The idea itself of the Big Bang is super robust because it just relies on expansion. If the universe is expanding, then you run the movie back and you get to something really hot and dense. So I know, for example, that the first images of James Webb challenge galaxy formation theories inside this universe expanding. But well, it's not going to challenge the Big Bang itself. I mean, it's going to challenge the expansion and the fact that if you go back in time, you get to something really hot and dense. That's super robust.
Doctor, at the time, at least it's been said, maybe you can confirm if this is true or not. At the time, there was a corner in the scientific world that pushed back against Big Bang cosmology, and it's been framed that the reason they kicked back was more ideological than scientific. In other words, they didn't want to possibly let the camel's nose under the tent in reference to Genesis 1:1. Is that true, or is that just a myth?
Oh, no. I think there's even a written letter by the editor of Nature, the English journal, scientific journal Nature, when he said that it suggests a beginning of something like this, and he found the idea disgusting. I think the word was disgusting. So it's not a urban myth, a legend of something like this. He had the beginning. Einstein himself, at the very beginning, said, Georges Lemaitre, I think, your math are good, but your physics is a disaster, something like this. So yeah, there was a big resistance, I would say, ideological resistance, even just so be it for, because it suggested the idea of a beginning, of being just because suddenly the universe itself is no longer static. So yeah, it's completely true from what I've read. Now, kind of quickly, people just surrendered to the data, the observation, and that quickly all the confirmations of general relativity rushed in, and people did better all the Hubble observation. By the way, for example, when you see that the Big Bang is really robust, is that Edwin Hubble made a mistake of a factor 7 is his measurement of distance. So and so from that, you deduced at the time, it was early 30s, that the universe was 1 billion years old. And there is in an appendix of a book by Einstein, a really interesting sentence where he say, the problem we have is that according to stellar physics, we know that some stars are older than 1 billion years old. And he say, I don't really know how we are going to get rid of this. But he didn't challenge the Big Bang. He didn't challenge the expansion. He said, well, the expansion is there. And finally, people from years later found the mistakes of Hubble. And so suddenly, the roughly estimated age of the universe jumped from 1 billion years to 10 or more than 10 billion years. And so the problem was solved. But the basic is just, I would say, qualitative. That's why when people found that Hubble had made a mistake of factor 7, no one went, oh, there's no Big Bang, there's no expansion, it's wrong. No, there's an expansion, just not at the rate we thought it was, but there is an expansion. Okay, it's like seeing something getting away from you, and oh no, it's not getting away at 10 miles per hour. It's getting away at 5 miles per hour. Okay, but it's going away from you. So that's really qualitative. It's not even quantitative. So that's Jeff's way.
Do you think that the pendulum has swung in the other direction now that there's so much data confirming the expansion that now a lot of scientists just think or conclude that there really was a whole beginning to the universe without considering what could have occurred during the Planck era?
So it seems the question is twofold. First, the question of the beginning is completely open. I mean, we know that a billion years ago, the universe has been to a hot and done phase and is expanding since then. And there are a lot of smoking guns of this. And I personally know, not personally, but I know but one cosmologist, Narlikar, is an Indian, who still advocates a steady state universe that was defended by Fred Hoyle. Fred Hoyle was a really bright British cosmologist, astrophysicist in general. But I think he's the only example around. All the rest of people I meet or I read or whatever, and for really good reasons, just do just agree with these broad lines that a billion years ago there was this. Now, about the beginning or not, and about the reason why we don't know if there was a beginning. So I'm going to make a long story short. Something really, I would say, frequent in physics is that the laws of nature we have their limitations. Okay. For example, Newton's law, they don't like too fast velocities. If you start to get close to the speed of light, Newton is going to start to give you wrong answers. Okay. Electromagnetism also. Electromagnetism tells you that the energy of a single charge here in vacuum is infinite. And of course, it's not infinite. Okay. If there were infinite energy somewhere, it would be well known. The dynamics, the equations that we have from 19th century is wrong on too short distances, because it makes the assumption that matter is smooth and continuum. And if you really look closely, it's not like this. So when you do physics, you are used to the fact that the laws we know, they have their limitations. They don't always describe reality. And you need to know these limitations if you don't want to predict strange behaviors. And general relativity, which is, I would say, the cornerstones of cosmology, also has limitations. And when you work out the equations of general relativity, you ignore the quantum nature of matter. You act as if matter was not quantum, which is perfectly okay in almost every settings we deal with. But when, for a few reasons, when a matter becomes really dense, then general relativity breaks down. We know it no longer gives right answers. And so if you run backward the expansion, you get denser and denser and denser and denser and denser. And at one point, you know that general relativity breaks down. And which means that before you cannot know anything. At least as long as you don't fix general relativity. And we don't know how to fix it. So to know if there was a beginning or not, we would need to know what happened before this moment when general relativity breaks down. And so far we don't know. All we can do is speculate based on various candidates on quantum gravity. So we know there was a hot and done phase long ago and that the universe is expanding. But before this, we can just guess. I hope I was not too long.
No, that's I think that's really helpful. There's an apologetics conference in my area this weekend, and the many of the speakers use an argument that if there was a Big Bang, that there was a Big Banger, or that the Big Bang means that the universe had a beginning caused by God. In light of what you just explained about not really knowing if there is truly a beginning because we don't have a solution to general relativity at the quantum level, what do you think about such arguments for the existence of God, or for God as an equator, a creator, when we don't really know that
Well,
information?
at the risk of making enemies, I think it's bad apologetic. Because, in a book, C.S. Lewis said something, I have the reference if you want, but science twisted in the interest of the apologetic would be a sin and a folly. And not most, but some of the scientific apologetic I see seems to goes by the rule, anything goes as long as it goes my way. And I don't think it's good apologetic. And the problem is that people get persuaded that the Big Bang has been proved to be the beginning, and that someone comes up with a scenario of bouncing cosmology, and they go, oh, so the Big Bang is wrong. No, the Big Bang has never been wrong. It's just that you didn't understand the Big Bang. So before this, what people usually call a Planck epoch, as you said, there are some speculation with a beginning. Stephen Hawking and James Hartle came up with a speculation with a beginning. You have many speculation without a beginning. If you go to some database of scientific articles and you type bouncing cosmologies, you will find almost 2,000 recent articles. It's an area of research really, really active right now. And the reason why there are so many speculations in so many directions is because we cannot so far test all the theories of quantum gravities, because there are a lot of candidates out there, but we cannot test them. And so I think that when an apologist come up and say, oh, it's been proved that the Big Bang was the beginning, it's really misguiding. Because maybe in the audience, people are going to get face crisis when they hear about other approaches, like bouncing cosmologies. And if someone informed from the outside, apologetics should be targeting people from outside, not people from the inside. And if someone from the outside who is informed hear about this, he or she gonna think, what are these guys telling? They are just telling themselves what they want to hear. But no, it's wrong. A friend of mine calls this apologetics in pajama, which means it's comfortable to be with it at home, but don't get out with this because people are going to laugh at you. And it's a little bit like this, apologetic from the inside, which means it's meaningless apologetic. It should be for the outside. Now, I do agree that if at the end of the day we find, if, for example, there was empirical or observational or experimental testing of the theory of Hawking and Hartle, then the universe had a beginning. And I do agree that it would become part of my panoply, I would say, my Swiss knife of argument for faith, because I do agree that if the universe had a beginning, that's something out of it must have decided tell him to begin. But so far, current cosmology is not there. And yeah, I tend to cringe each time I see an apologist using this argument because it's dangerous.
Are there other reasons to think that the universe might have a beginning that's not cosmological related, like philosophical or mathematical reasons?
Mathematical, I don't know. I hear from time to time this argument, rather philosophical, that if there is an eternal past, then you need an internal amount of instant to get to us. And I have really a hard time being convinced by this. Because it sounds a little bit to me word salad. And from math, no. And from physics, I just told you neither. So for me, the question is still open. Now I heard of some, I read in Swinburne, this British Christian philosopher, that there is some equivalent of the Kalam argument, but they works even in a past eternal universe. For you can always wonder when is there something rather than nothing. And that doesn't depend of whether the universe is eternal or not. It could just not be there.
Yeah,
so
I
that's
definitely
more general.
Yeah, I definitely prefer the ontological argument rather than the Kalam, just because I don't know that we haven't established that the universe has a beginning.
Yeah.
So we haven't established that there needs to be a cause to begin it. Exactly. But it is still a good question to ponder. Why is there something rather than nothing?
Yeah.
I do want to come back to this general area because I think that's what we really want to talk to or address is modern apologetics' use of the Big Bang as evidence. But Dr. Clark Van Gilder has chimed in about the other side of the conversation in Christianity that saw the Big Bang as a threat to biblical authority and to the whole story, because it does, as you say, Doctor, have a couple smoking guns as to the age of the universe, the age of the earth, and so forth. So he writes, creationists like to claim that the Big Bang theory is full of holes or doesn't match reality, etc. What, if anything, lends merit to such claims? What are the actual weaknesses of the Big Bang theory?
So again, I'm going to try to be quick. I wouldn't say that the idea that long ago the universe was dense and hot and is expanding since then has any weakness. I mean, it's an observation. Now, what people usually call weakness, and that you can understand, is that when you look at this, I would say, a primitive universe, there are some features which, according to known physics, don't match. For example, you find that that's called the horizon problem. And that was presented by physicists themselves, No, I was about to say something bad about creationists, but I will refrain. For example, you find that two remote places of the sky seems to have been in touch with each other long ago, although according to the part of the story we know of, they didn't have time to be so. It's called the horizon problem when you find that the cosmic microwave background is remarkably homogeneous in every directions. And when you think a little bit about it, you say, oh, how is it that this direction is homogeneous with this direction? Because these two parts of the sky didn't have time to talk to each other. Or you find that according to known physics, there should be in the universe, there should have been as much matter and antimatter. And when these guys annihilate, there's no room left for matter. So even within known physics, you have escape from this. But these are big, I would say, mysteries. Now, the way I see it is that it's completely normal, because this state, expanding hot and dense state long ago, that we call, I would say, the Big Bang, comes from a phase which physics is not known. And when you deal with unknown physics, it's completely normal to find something strange. For example, 100 years ago, a little bit more than 100 years ago, when people found out that in an atom you have an electron turning around a proton, okay? There's a famous article by Niels Bohr in 1913 when he writes, that's awkward because according to known physics, this cannot exist. Of course, the idea was not that nature is wrong. The idea was, okay, there's something we don't understand. And then came quantum mechanics. Here, I would say it's the same. We know that this phase we understand comes from an earlier phase we don't understand, and it's completely normal to find things that are awkward to non-physics. So that's, I would say, one angle of attack of the Big Bang, which eventually rely of understanding the limit of the theories and understanding that theories have their limit, and the concept of an era in the history of the universe, which is described by a theory we don't know. Another angle of the attack is dark matter and dark energy and all that. And here again, first, how do these guys pop up? When you do some observation, but many observation, not just the expansion or just studying the CMB, but looking at gravitational lenses, or you look at the galaxy cluster and you see some hot gas inside, and you can deduce the mass of the cluster, all that. When you cross all these observations and you use general relativity to describe them. In general relativity, you have in the theory we use that gets out of general relativity, there are a few adjustable parameters, and you use all these observations to determine the value of these adjustable parameters. And I should add that many different observations give the same values, of the same range of values. And then you ask, okay, physically, what are these guys? But you see, it's kind of two different things. You have a theory, general relativity, which we know should work in these settings, okay? And it has one parameter there and one parameter there, and it doesn't have a lot of adjustable parameters. It's kind of rigid. And so observation tells you, oh, this parameter at this value, this parameter at this value, and then you wonder why, okay, what is this? And here there is a big unknown right now, two big mysteries. You find that most of the matter that is supposed to be there because you can weight it, you don't see it, okay? That's dark matter. And you find also that apparently vacuum has an energy. So from quantum mechanics, we know it should have an energy, which is not zero. Now there's no theory giving you the value of this energy that you can derive from just observation. So many people attacking Big Bang don't like it. But you know, the idea of the Big Bang was born long before this. Was born before dark matter, was born before dark energy. Again, the idea of the Big Bang is just qualitative. You have an expansion, you rewind it, and you get to a dot and done phase. So that's why it's so robust, I would say.
Yeah. I hear sometimes people talking about, since there are things we don't know yet, maybe the universe really is only 6,000 years old, that we'll discover something that will completely change, debunk any data that says the Earth is older than that, or that the universe is older than that. And you wrote a book on the age of the universe. So is it reasonable to think that we're just close to some new discovery that will make us think the universe really is only 6,000 years old? Is that a reasonable conclusion when we don't know things?
It's like expecting people one day would say, oops, we were wrong. from New York to Los Angeles, they are just 3 meters. Or Spain is 50 centimeters wide. It's not going to happen. So indeed there is a debate on the hydrogen universe right now, because there is a debate, what people call tension, on the measurement of the Hubble constant, which almost directly tells us about. So the hydrogen universe is a shortcut to how long has been since this hot and done phase in the past that has been expanding. That's one of the many confusing expression in cosmology. People typically call about the edge of the universe, and then when you press a little bit and want to explain, oh no, there's an era before, we don't know what happened. So it's not really the edge of the universe, but when people commonly talk about this, they talk about how long was the Big Bang, the edge of the universe. So that's point first one, but we already discussed this. Point first two, there are so many observations that should be wrong, invalidated, for the edge of the universe, the time since the Big Bang, to come back to 6,000 years old. It's not going to happen. For example, the measurement of the Hubble constant now, which tells you the rate of the expansion. So you can imagine that if you know the rate of the expansion, you know how long ago then it went galaxies almost touch together. And so it gives you a lower bound, I would say, of the edge of the universe. It's about 70 kilometers per second per megaparsec. So megaparsec is a cosmological unit of length. Million of, and a parsec, I think it's 3 light years. So a megaparsec is a lot. But it tells you that two galaxies distant by 1 megaparsec, they just run away from each other at 70 kilometers per second. But the number is 70. And from them, you deduce 13 or 14 billion years old. Okay. To deduce 6,000 years old, the number of the Hubble constant should be 600,000. There's no way people are going to say, oh, sorry, it was not 17, it was 600,000. There's no way you can do such a huge mistake of measurement. The debate is between 68 and 72. Okay, and there's a big debate there, because depending on the way you measure the Hubble constant, you don't find exactly within measurement error, within error bars, you don't find the same values. And by the way, it's kind of fascinating, because sure, we're going to learn something, but it's not going to jump to 600,000. So there's no way cosmology is going to come up and say, oh, we were completely wrong, now it's 6,000 plus. I'm not an expert in this, but you have evidence from biology, from geology, from plate tectonics, for example. So there are so many evidences right now. By the way, there was a debate on the age of the Earth even before Darwin, but the debate was about how many millions, not about how many thousands, and even before Darwin. So debate was 10 million years old or 20 million years old, okay? But it's been at least 2 centuries since the debate is not about 1,000 years old. Is it 6 or is it 5 or is it 7 or is it 10,000? No, it's been 200 years old since from every corners of science. We first talk about millions and then billions.
Dr. Kristine brought up that apologetics conference that's just down the street from her house, and we talked about the 2 different Christian views of the Big Bang. The Young Earth Creationists see it as a lie of Satan and an enemy, but most of modern apologetics is really embraced in an old kind of Muslim argument. I think it was first brought up by Islamic scholars, called the Kalam cosmological argument. Basically, it says that everything that has a beginning has a cause. The universe had a beginning, therefore the universe had a cause. And then there's an existential leap from that to the creator of the universe is the God of Abraham, Isaac, and Jacob. I'd like to get your comments on that argument. Is the Kalam something that you think is a good argument, or do you think the weakness there is built on that first premise?
Oh yeah,
Christine
asked me about it. Christine asked me about it. To make it short, because we discussed this a few minutes ago. No, I don't think it's a good argument, because you pretend current cosmology claims something it doesn't. So from time to time, yeah, people talk really roughly and say, "Oh, the beginning of the universe and what's the age of the universe or whatever." But when you look a little bit into details, and not even into too much details, when you just wonder, okay, are there some limitations to general relativity? Does it have some domain of validity or whatever? Of course it has, and it's not a mystery. It's in textbooks.
Well,
you look in textbooks of general relativity.
Let me rephrase it this way then, because these same apologists say that the Big Bang actually shows that matter, energy, space, and time all came into existence at that point. What about that statement is not accurate?
Oh, we just don't know. I mean, some speculations give this, like Hawking and Hartle, but we don't know if it describes reality, because each time it's based on theories that couldn't be tested so far. So that's why you have so many theories of quantum gravity out there, because observation or that could invalidate or validate some of the theories, they are really, really difficult to do, if not impossible so far. So far, cosmology can take you to reliability, I would say, cosmology / physics, to a phase really, really hot and dense, when you could state that something like all the matter we see today in the observable universe was contained in a sphere 1 centimeter or 1 millimeter or something like this. That's completely trustworthy, because from there are empirical conclusions that then you can observe, like light element abundance. There's even something which is called not cosmic nuclear background, but cosmic neutron background, which is predicted by this scenario, and that has been found. But before this, and in physics, when you eventually find out the right theory, you may have completely unexpected consequences. So for example, when people found quantum mechanics, suddenly you understand all the periodic table of the chemist. All chemistry comes from that. These entanglement, quantum entanglement, this weird stuff come from that. So that just from quantum mechanics, the answer to Niels-Bohr question, what is this electron doing turning around this proton? It shouldn't be possible. Where you find quantum mechanics and you find a huge, I would say, continent, universe of new phenomena. And so I wouldn't expect quantum gravity to give some dull answers. So maybe the answer will be, the day we have tested the theory of quantum gravity, will be yes, there was a beginning of matter, time, and all that. And in that case, people were right. People who I would say bet on this were right. But maybe there was a big bounce in the past, and with an universe before. So far, everything is on the table. And so far, claiming that this has been proved is wrong.
I find it kind of like really interesting to think that there's so much we still don't know. I mean, that's what an opportunity to study the universe around us. Obviously, looking into quantum gravity is a huge field of unknowns that will be interesting to hear what we learn in the future. And if we do solve that, it'll be really fun to see the implications for the early universe too. You've also written about energy and climate science. So I was thinking it'd be fun to just switch directions a little bit, and I'm going to be in the market for a new vehicle in a year or 2 or 3. We have a pretty old vehicle, and when it goes, then I'll be getting something new. And how green are electric and hydrogen powered vehicles? Are they a good investment at this time? Are they? I have a friend who had an electric car, and when the battery got old enough, they bought a different car that's not electric because they didn't want to replace the battery. So tell us a little bit about your research with energy and climate science, and how good are electric and hydrogen cars right now?
Just bypassing, it's not my research, it's my teaching. When I came to Spain in 2004, my research was on nuclear fusion, and I wanted to have a big picture of the energy problem. Frankly, at the time, I didn't even know about climate change. And so I signed up to teach a course on climate and energy. And maybe you've noticed, but teaching is a wonderful way of learning. And so I taught this, and so I've been teaching it for almost 20 years. And years by years, I work with students, and one of the projects we work on with students was this one, which has been published by Springer. How green are electric cars? And so basically, the reason why it makes sense to ask the question is because, of course, the car per se doesn't emit CO2 when it runs, because it runs on electricity, but you need to do the electricity which goes into the car. Okay. So in physics, there is a really strong principle, which is that energy is conserved. And when you have energy somewhere, it must have come from somewhere else. Energy is not free. Okay. And so if you have energy in the battery of your car, this energy came from somewhere. And so, for example, we found that if you made the electricity burning coal, where you emitted more by burning coal to make the electricity for your car than burning oil directly in the car. Okay. But it's if you make your electricity 80% or 90% with coal. For example, in China or India, I think electricity comes from coal at 70% or 80%, something like this. So now we just assess, I would say, compare the emissions of the running car. So on the car running on oil on one side, and the electric cars running on electricity on the other side, and how much do you emit doing the electricity? And we found that depending on your electricity mix, you may emit more or less. So of course, if your electricity is 100% non-emitting, like nuclear, wind, hydro, or this, well, at the end of the day, you emit zero. Now, if your electricity, on the other hand, is made from a coal or oil or whatever, or gas, where you emit more by making the electricity, that goes into your car, but then by burning oil in your car in the first place. Now, something we didn't assess, and that's related to a question, is comparing the emissions of making the cars and then on recycling the cars. And I know people, I haven't looked at it. I know people have done some studies on it. I haven't looked at it. So I don't know the answer, but that's of course a big part of the equation that we didn't treat. And I can suspect that recycling a battery is almost not free. I would say free from emissions. So that's what I can say so far. So on what we did.
All right, that was really interesting. Thank you. Should Christians even care about climate change, and how reliable is climate science? Is that just all politics, or is there something there that we should be concerned about?
Oh, I would say that the basic science involved is super simple. It's 200 years old. I think the atmosphere acts like a blanket in your bed. And the first one who came up with the idea was Joseph Fourier, a French scientist 200 years ago. And then by the end of the 19th century, Swede, Arrhenius, did the calculation of how much are going to would we warm the planet if the CO2 was just doubled. And the reason why CO2 acts as a blanket also, it's really simple science. It's energy conservation plus quantum mechanics. Quantum mechanics tells you that if infrared radiation goes to CO2, CO2 is going to catch it. So the basic science is really simple. And I like to show a study that was done by ExxonMobil in 1982. And you cannot suspect ExxonMobil as being horrible, lefties, green, nasty guys, okay? And they were right. If you look at they consider a business as usual scenario, which means we don't care about anything and we keep on burning fossil fuels. And you look at their report. Their report is still on their website. I've checked 2 days ago, okay? Because each time I made a presentation about it, I made a presentation to my students because I'm teaching this right now. So each time I made a presentation, I check it because I want to be able to take to my students. It's still there. You can go and check. And they were right on target. They made some predictions of global temperature, considering a business as usual scenario. And if you look at the number they predicted for 2020, which is 40 years ahead of their time. I remind that the report was published in 1982. They predicted what we have of CO2 in the atmosphere right now, which is 420 ppm, and global warming on 1 or 1.2 degrees Celsius, not Fahrenheit. It's more complicated when you start to look at a local's prediction. This is global, and the global business is really simple. Well, until now it was really simple. Now it may become more complicated. I can comment on this if you want, but the global business is simple. Now, the tricky part is to do prediction for India, for South Africa, for Minnesota, for Arizona, something local. That's more difficult. But if you read the Nature or Science or attend the big conference like American Geophysical Union, I've done it twice in the last 10 years. No one no longer talks about, is there really warming or where is it coming from? That's no longer on the scientific agenda. I mean, this question has been solved 20, 30 years ago. Now it's more, what can be the consequence of this and that, and what about the permafrost? Can we have negative feedback? Also a lot of local prediction, like what for the US, Eastern US, Western US. Okay, but the big business, global temperature is not really complicated.
Doctor, it's interesting you say that there's no real controversy about whether it's happening or not, at least not for the last 20 or 30 years in the scientific community. one of the things that binds the two sides of Christianity that we were just recently talking about in regard to the Big Bang, which is young Earth creationists and old Earth creationists, is this unhealthy skepticism of expertise and of science itself. So something that brings these two groups together is skepticism on global warming, which is often couched as a political and not a scientific argument. In your opinion, can we recover from that as in this generation as a church, or are we kind of wandering in the wilderness? I mean, this is an important subject to Kristine and I because so many young people list an anti-science or science denial attitude within their faith as a reason for walking away.
Mm-hmm.
Well, so short answer, I don't know. Now, to elaborate a little bit, I would say first, situation in the US is not the same as in Europe. There is, for example, in the church in Spain, I would say the Protestant church, okay, not Catholic. Protestant church, people have some trouble with biological evolution. The age of the universe, not so much. Vaccination, not at all. And climate change, not at all. I mean, I never heard of anything like this. In France, biological evolution, also a lot. Age of the universe, not a lot, a little bit. Climate change also is there. Age of the universe also is there. Precisely 2 or 3 weeks ago, there was a big conference, Young Earth Creationist conference in France for the first time. Not for the first time, but it's coming. Okay. But it's not really widespread. And in Spain, climate change skepticism in the church is, I never heard of it. Okay. Now in the US, it's a much larger issue because with a friend of mine, we talk about ideological pacts. So it seems that some people are almost predictable. If you advocate nuclear energy, then you will be on the right, then you will be a Christian, then you will be pro-Israel, then you will be a climate change skeptics. Maybe a problem with evolution, maybe Young Earth Creationist, but kind of pack, And if you don't advocate nuclear energy, then you will be green, and so you will be a leftist, and you will advocate, and you will be pro-Palestinian, and you will be against religion and all that. And I don't really see how you can. So as long as these two packs are held by 10 guys here and 20 guys here, well, kind of you don't care. Now, when they held by 40% of the population here and 40% of the population here, then I don't really know how you can get rid of this, except on the long run by, I would say, education. I mean, teaching people that, for example, people from time to time are surprised when they say, oh yeah, I completely advocate nuclear energy. That's part of my research. And yeah, I teach climate change. And I have a big issue with groups like Greenpeace. Because for me, they are partly responsible of the climate change. But now they cry like babies. We need to fight the climate change. Oh, you did it, guys. So, but that will be another long story. So how can you get rid of this? A part of the long run, I would say it's by education. But in short run, and you see if you were raised in a setting, be it church or family, where from your very young age they taught you this, and then you went to a Christian college when you taught you this, and then you went to a Christian university when you taught you this, I completely understand that your horizon gets really small, and it's super difficult to get out of it. So in the short run, I wouldn't like to be Joe Biden. Okay.
Yeah. Well,
Just to
I think it's
reconcile.
even worse than that too, because now you've associated your Christianity with these specific views on climate and evolution and the age of the Earth and Big
And
Bang and
abortion also.
all
Although
of
there
these
is a
things,
big one.
and it's emotional and it's tied to your faith
Yeah.
and to being a true Christian, and education that shows that you're wrong on even one or two of those pieces can have a tremendous uh, impact in a negative way on faith and cause faith crises and lead people to conclude that if their church and their Christian heritage taught such false things about, and some of the science is pretty simple, and a lot of it is so very well established. If Christianity is wrong on those things, maybe it's wrong on the pieces that are a lot harder to investigate and have empirical data for them. How do you believe in the resurrection when there's not empirical data on that, when you see the church is so wrong on things where there is empirical data? So that's a concern that we have, particularly the church in America, where these lines along politics have gotten so ingrained into many churches.
Yeah, I think, for example, that someone I guess, Catherine Hayhoe.
Yes.
You know her. So I know
Well,
her
not
also
personally,
because
but yes.
yeah, but I think she's helped me tremendously. Yeah, I'm an evangelical. I'm married to a minister, and I'm a climate scientist. And yeah, it's true, guys. There is a climate change, and we are at the root of it. So I think it's good to have public figures like this who are in between the blocks, the packs, okay, and say, oh, there's a life in between. There's no reason besides ideology to be all on that side or all on that side. If you just so I think these people help. I think also what you do help a lot to offer an alternative to this polarization, which is completely useless. But I see things that help now. How can you get out of this? I don't know.
Maybe not by sending the youth group to the anti-science apologetics conference.
Oh yeah.
Jessica Mormon is another example of a climate scientist whose husband is a pastor. And I know she's going to be speaking at the American Scientific Affiliation's Winter Symposium at the end of January, too. So that's another really great resource on climate.
Who are you talking about?
Jessica Mormon. She's a climate scientist.
Sorry, I don't know.
Okay.
But I think it's useful to put forward. I know Catherine personally from long ago, and she told in a testimony that when she first met people in her church back in Texas, people told her, "Oh, you're a climate scientist. I hope you are going to tell us that all these guys, they are wrong." They say, no, "Sorry, they're right." But suddenly, because you're evangelical and because you're the wife of a minister, it's disturbing, but can you tell me more about him? Because so it's unsettling, but suddenly something opens up. So I think it's really good to reconcile this, to have a public figure like this.
If you need another reference, viewers, if you're watching this, there is an excellent documentary on the subject called Merchants of Doubt, which kind of goes into the psychology of why so many Christians reject this. We've been sold a story from the same people who really said there's nothing wrong with nicotine, that basically arguing against climate science. And that was really eye-opening for me, not only to watch that documentary, but to read the book that inspired it. So just throwing that out there. Yeah.
Well, we're getting past the hour mark, so we probably should be wrapping up. It's been such a delight to have you with us today, Antoine. Do you
Thank you
have
very
any other
much.
thoughts that you would like to share just in closing on, um, the process of reconciling science and faith, or how to hold both and be a faithful Christian? Any final thoughts you'd like to share?
Yeah, I would say quickly, and maybe it's at the root of the discomfort. So it seems to me that there are two roots of discomfort with the Big Bang. One is just the billion of years, okay? And the other one is, the Bible says God did the universe, so it's not the Big Bang. And I found that there are many Christians have problems with finding an explanation, I would say a mechanic explanation of scientific explanation for something that, according to the Bible, was done by God. And that's a question I asked myself from the very beginning of my Christian life. And I found that this idea of if the Bible says God did this, it must be a miracle, is not even in the Bible. And the best example I know is Jesus saying, God feeds the birds. Okay. And we all know how it happens, and it's not a miracle at all. And so from time to time, Christian seems bothered by the fact that, the Bible says God did this, and so it must be a miracle. It must be instantaneous, popping out of nowhere. And the Bible itself doesn't even teach this. And then from there comes all, I would say, I would call the God of the gaps apologetic. Then people, to prove God, need absolutely to find something that science doesn't explain or can't explain. Look, it's a proof for God. Well, God doesn't need any gap. So I think that's also a big issue in apologetic. But besides this, thank you very much for inviting me to talk. And it's been a pleasure.
It's been great having you.
Thank you, Doctor.
So.